Hello, and welcome to a new kind of mini-series. We're going to make an endless runner. So it's going to be like the Minecraft tutorial series, but this one's for making an endless runner, and it's going to be much shorter. Possibly 2, maybe 3 videos. Maybe 4 if I can think of something interesting to add. Definitely at least 2 videos anyway. And we're going to make it using this free Voxel Dungeon Environment set by Fully Beta. I'll obviously have a link to that in the description below the video. So without any further ado, let's get straight into it. So far, the only thing I've done beforehand, other than import the asset pack, is I've created a couple of little prefabs using those assets. This is a piece of plain floor made using individual cubes from the asset pack. And then I've just slapped a collider on it, although that's not going to come into play on this one. Now, the important thing about this and any other, like you can use any asset packs you want. You could use this asset pack, you can make your own assets, however you decide to do it. The important thing is that the length, so that is the Z axis, the distance from the start to the finish, needs to be the same for all what we're going to be calling level pieces. So the length needs to be the same. In this case, it's 3.6. From this edge to this edge is 3.6 Unity units. So let's go into our scripts folder, create a new script, and we'll call it level controller, and we'll open that up. And before we get into any code for the level controller script, we're actually going to make a little class, and that class is going to be for the level pieces. So we're going to want to edit this in the inspector. So straight away we'll make it serializable, and then it's going to be public, obviously, and we'll just call it level piece. And it's going to have for our own convenience, it's not really important to the game, but we're going to have a name, just so we can give it a name so we know what each piece is without having to open up the prefab. It's going to have a prefab. And it's going to have a value called probability, which will be an integer. And we're going to give that a default value of 1, and I will explain that later when we get to using that value, but for now just ignore it. So into our main class, into our level controller class, let's create an array of those level pieces that we just made a class for. And that we're going to be able to edit in the inspector. We're also going to need a reference to our camera transform, because we're going to need to move our camera. We will have a draw distance. That'll be it for now, actually. So if we go back to our game and create an empty object, which we will call level controller, reset the transform, and we'll drag our level controller script on here. Drag in our camera reference. Our draw distance for now we will set at, we'll go with 35. And then level pieces, we'll just give it 1 for now. Call it plane floor. And I'll go into my prefabs and drag in plane floor. So in the level controller, I'll just give that a probability of 1 for now. That's all we're going to put in. So if we go back here, and in our start, we'll just do a simple for int I equals 0, I is less than draw distance, I plus plus. And then for each one of those pieces, we're going to spawn in a new level piece, but we need to know where to spawn it in. So let's just do game object new level piece equals instantiate. And we're going to be using a level pieces index 0, because at the minute we only have 1 piece. We'll get to using it properly in a little bit. And then for the position, new vector 3, our x value is going to be 0. We know it's 0 because we want everything dead in the middle. We're moving along the z-axis. This is just, we're not going to be doing any fancy turning left or right on this one. This is just going to be a straightforward runner. So we know the x is going to be 0. We know the y is going to be 0. The z is where we're going to need help. So the way we're going to do this is we're going to store the length that I mentioned. So public float piece length. And then just quaternion identity, because we don't want to add any rotation to it. And of course, don't forget to add the prefab part there like I did. And oh yeah, sorry, and the piece length obviously wants to be times by I, otherwise we're just going to be putting them all in the same place. And then if we go into our game, we set our piece length, which as I mentioned is 3.6, and we run it, we should have a line of platforms. As you can see, that I've already put the camera in the right position, by the way. The next thing we can do is we'll create ourselves an update method. And in the update method, we just want to advance our camera position. So we'll give ourselves another value, which we're going to call public float speed. And then our camera dot transform dot position equals vector3 dot move towards. And then we're moving from our camera dot transform dot position to camera.transform.position plus vector3.forward, and we're going to increment by time.delta time times speed. And then for our speed value, we will give it a 3, I think, is a nice steady pace. So we have the basics of what looks like an endless runner. However, as you may be noticing on screen, or if you've been following along with the code, we're rapidly running out of running space. Like the platforms are coming to an end. So we need to make it so that, I'll just pull some plain floor pieces up here to demonstrate. So basically the way we're going to handle this is we're going to have our pieces. If you imagine this is a long line of pieces, and as the camera moves along, we're going to, for now, we're going to destroy the closest piece to the camera, this piece here, and then we're going to create a new piece here. So it just essentially keeps moving that way like that. And for now, we're just going to destroy and instantiate. We will maybe, if we feel like we need to do another video on it, we'll maybe optimize it so that we're reusing the same pieces and not wasting overhead on instantiation and destroying objects. But that's how we're going to handle it. So back into our script, we'll just go here. We're going to create a queue of game objects, which we'll call active pieces. Then we're going to take this and we're going to put it into its own function. Now, we need another value, and what this value is going to be is it's going to reduce the camera position to a level piece number. So as the camera moves along, it starts off, it's over what we're going to call level piece 0, and then as it moves forward, at some point it will cross over to level piece 1, level piece 2, level piece 3. The way we're going to keep that value is we're going to need 2 ints. One is going to be called current cam step, which will equal 0, and then the other one is going to be called last cam step, and that will also equal 0. Sorry, just in here, we're going to call that spawn new level piece function. So our current cam step is going to equal, it needs to be recast as an int because these are going to be floats that we're working with, but we want an integer value. Camera.transform.position.z divided by piece length, and it's that simple. And then last cam step is just going to equal current cam step. And then in our update, we'll do a little check to see if that has changed. So we can just copy this line because that's always going to be the same bit of code. So we reset our current cam step, and then we say if current cam step does not equal last cam step, then we want to reset our last cam step to the current cam step because it means that we've moved into the next level piece zone, region, whatever you want to call it. And then we are going to want to spawn a new piece. Now we're also going to want to despawn the last piece, and this is where the queue is going to come into play. Now that we have this current cam step, we have a way of telling how far in world space we've moved. So if we go down here, obviously this no longer applies. The way we're going to do it is when we create a new level piece, we're going to add that piece to our active pieces queue. We can't tell what's in our queue in terms of like a list or an array. We can't look at the actual items in it, but we can tell how many pieces are in it. So with that in mind, we can, instead of timesing piece length by I and just iterating through it, we can do active pieces dot count plus current cam step, and then times that by piece length. Now, actually, to make it make sense a little bit more, let's just move that to the start, because think of it as current cam step is essentially like a starting position, so that's where the camera is now, and then we're saying plus the active piece count, which is the amount of pieces that we want in front of the camera at any given time, our draw distance. We times that by the level piece, and that gives us the start position for the next new piece that we're adding. And then for the despawn, which we'll just call despawn level piece, we say game object old level piece equals active pieces dot dequeue. So that removes it from the queue, and that's obviously that keeps the number of items in the correct place. And then we just want to destroy that piece. And if we go back up to here, we also want to, actually we want to destroy before we add the next piece, otherwise we're going to end up with an incorrect draw distance. So if we go back into our code now, and I'm just going to make the draw distance a lot shorter, just so it's a bit easier to see it in action, and I'm going to zoom out a bit here. And if we play it now, we should see, there we go, as our camera moves along, our world moves with it, basically. So we've got our basic system set up. Now we want to add in some new level pieces. So I've got my 3 prefabs. I will drag them in now. We've got trap floor and pit floor, and we'll name them as such. Now we have this probability value, and this is where this is going to come in. So what we're going to do with the probability value is we're going to create a list of integers. And in this list of integers, we're going to store one integer for every, the integer represents the index in our level pieces array. So if our probability of, say, level piece 0, which is just plain floor, is 10, then we're going to have 10 zeros in this list. And then if the probability of pit floor is 1, then we'll only have 1 of whatever index that is in the list. And then when we need a probability, we're just going to get a random integer from this list. And obviously there are going to be 10 level piece 0 indexes, but only 1 level piece 2 or whatever it is index. So there's a far higher probability that we're going to be getting the level piece 0. And that's how this probability list is going to work. So we'll just call it probability list equals new list int, and then we're going to create a new void, which we will call build probability list, and then int, we need an index equals 0 for each level, no, sorry, that wants to be capitalized, level piece in level pieces. So for each level piece, we're going to do for int I equals 0, I is less than piece dot probability I plus plus. So we're looping through each level piece, and then for each level piece we're incrementing the amount of times that we've set in this probability value here. So right now it would be 1 for each of them. We're going to change those values shortly. So for each one, probability list dot add, and we're going to add that index value. And then once we've done with this particular level piece, we want to increment our index value to the next level piece. And you could use this as a regular for rather than a for each. We're going to call that up here. And then we're going to use it here. So we'll say int piece index equals probability list, and we give it index, which will be random.range 0 from 0 to probability list dot count, and then we will use that value there. So if we play now, it should be a fairly even spread between the 3 different types of level piece. But obviously we don't want it to be quite that harsh just yet. So what we're going to do is we're going to increase the probability that we get a regular plane type floor. We'll say trap floors, we'll keep them at 1, they want to be a bit less, and we'll say 2 for pit floors. Let's make that 5 actually. So now we should have a bit more of a forgiving type of floor, level design. And of course, these values can be modified as the game goes on. So you could make it so that the level gets like the probability of hitting a trap or a pit or whatever object types you have added in there. You could make it so that that probability increases as the game progresses. So that's nice and simple. So the last thing we're going to do, that's pretty much it for this video, by the way. The last thing we're going to do is I'm just going to bring that back to 35. And we're just going to add a little bit of atmosphere. And the way we'll do that is main camera, we're going to turn it off of skybox to solid color, make it black. We're going to go into our rendering lighting settings, down to fog. I'm just going to play the game so I can see the level. Pause that, just so I can mess around with these settings while actually seeing what's going on. So density 0.5. I want to make it black, sorry. That's maybe a little bit too foggy. Helps if you go the right way. Yeah, that looks about right. So there we have the start of our Endless Runner. In the next video, obviously, we're going to put in the runner part. We've got the endless part. So we'll add the runner part, and as I say, there's possibly a 3rd video in this series, which will be, if I don't fit it into the runner part, it will be adding things to collect. And maybe we'll go over on score, sorry. Yeah, you need to have a score in an Endless Runner, otherwise there's no point. Next week will be a Minecraft video, because I know that's why most of the people that subscribe to this channel are subscribed to this channel, so don't worry about that. And then the week after, I'll probably do another one of these. This is something that I thought was just a nice, interesting, quick little video. Hopefully you guys like it, and we'll see you with the next Minecraft video next week. Bye-bye.